So today we're talking about permutations of liked objects. So we're asking how many permutations can we get of this word Woolloomooloo. So Woolloomooloo is a place in Sydney, but more importantly it gives us a real challenge. So first off, what we do is we count. Let's count how many W's there are, and we find there's 1 W, 3 L's, 8 O's and 1 M. So if you want to double check, you can pause the video to double check. So we need to rearrange these letters. We find that we often have words that are the same. So it's because switching like letters does not produce a new permutation. For example, if we look at just the first 4 letters, W-O-O-L, if we make one of the O's blue and we switch it around, and what we get then is W. That's not a new permutation. So what we have to do really is label them to work out how many permutations we have. So the number of permutations of n objects, so of all the objects we have, when we have ones that are alike, we have a special formula for. So the formula is n factorial, which is how many we have in total. So in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n equals 13. And we have some items that are alike. So we put down the bottom, we divide it by how many items we have that are alike. So we don't need to put the 1 factorial, because 1 factorial doesn't really change our answer. But we have our O's, so we have 8 factorial, because that gives us our O's, times by 3 factorial to work out what it is. So this is our O values, O's that are the same, and this is our L's that are the same. So this one is 13 letters in total. So if we were to write out a formal definition, what we get is the permutation of liked objects of which n1 are alike, n2 are alike, all the way up to nr. Now what does that mean? This means we might have one object that is alike. We might have 2 objects that are alike. We might go all the way to 100 objects that are alike. It doesn't really make a difference. We are able to work out how many permutations there are by the following formula. So the formula is n factorial over n factorial of the first like object times by n factorial of the second like object times by all the way through to n factorial of the final object. And what this gives us is the number of unique permutations. So if we want to try something completely different, okay, we're talking about the words identical. We say in a drawer we have 5 identical knives, 3 identical spoons, and 6 identical what could we say? 6 identical forks. Okay, so the question is, how many ways can these be set up in a line? How many ways can these be ordered? So what I want you to do is to pause the video and try to work it out. So welcome back. What we're going to do first is, I hope what your first step was to find out what n is. So how many objects? So it's really easy to work out. We add them all together. So we have knives, spoons and forks, so we get 5 plus 3 plus 6 to give us the answer of, sorry, I don't know why I put a bracket there, 6 and 3 is 9, 14. So we have 14 objects, and we can put 14 factorial over, okay, all the objects that we have that are identical. So I have 5 factorial for the knives, 3 factorial for the spoons, and 6 factorial for the fork. So once you work this out, you just double check your answer. So there's some things that we need to be very clear on. So permutations are ordered objects. Switching like objects does not give you a new arrangement. And like with restrictions, sometimes it's easy to deal with the objects and the restrictions first before it is to go on and try and work out the answer. So try have a go, make sure that this answer is like the one person next to you.